What this is about is on how to efficiently combine open data. We have a lot of data in what I would call silos, things. RIPE NCC collecting a lot of data. There's PeeringDB. There is the IXP DB. There's loads of data everywhere. And how do you actually combine these types of data effectively? We've been breaking our head over this, and Romain has come up with some nice ideas here. So I'll hand it to Romain.
Okay, thank you very much, Emile. And so let's dive into the slides. So the premises of this work are quite simple. We, and here I just mean everybody on this call, like we researchers, operators, peering coordinators, we are constantly looking for knowledge about the internet. And this knowledge, then we're going to use it in a daily task. And this is something we are all using the same database. Like we are going through RIPEstat, PeeringDB, WHOIS, bgp.ht, and we are going through those databases and try to understand something about the internet, so we can use that. What is interesting with those databases is we need all of them. They provide different views, but sometimes they might be a bit hard to use because they also have a different definition for the same thing. And working with Emile, as he just mentioned, we always found that he knows a lot of new database I didn't know, and we saw that there is probably a better way to use all this information and put it together. So that's the goal of this project was how can we design a platform so we can really share all the knowledge we get from these data sources. And we want this platform to be as open as possible. So anyone can add new data to it. We want also this to be as a structured database. It's not just like a repository where you push dumps of your data set, but really like we want like all the data points from the different data set to be interconnected. And of course, this is pretty hard if we use a fixed database schema. So we want a platform that is very extensible to do that. And we discussed a lot about this topic with Emile. And one thing that really caught our interest is knowledge graph. And without giving too much detail, knowledge graph is it's quite simple. It's simply graph structure where you're going to put your data in it. So in the graph here, each node will be a data point, and you can see that they all these data points going to have a relationship between them. We've been inspired by a different knowledge graph. The one that we look the most at is Wikidata, but there is other like famous graph from Google or Facebook, or there is one from the CIA, the World Factbook, that is quite famous too. So to implement our very experimental platform, we looked at one implementation in particular. It's called Wikibase. It's a software that is developed by the Wikimedia organization, and it's the software that is running behind one of their websites called Wikidata. So Wikibase is mainly a graph database with all the wiki tools around it. So it's of course it's open source, so it's very easy to start with. And because there is a big community behind it, there is a lot of built-in tools. Just to mention a few, there's like a Python library to access to it. There is a nice querying UI using SPARQL, and they have different web interfaces. And if you go to the Wikidata page, you're going to see that there is some information about networks, but it's very, very general. For example, if you go to the IAJ page, then you will just see that so IAG is one of the nodes in the graph, and it has different properties. And it's going to be like it's IAG, it's an enterprise, it's an ISP, it got a logo, image, it's in NASDAQ, etc. So it's very general, and it's not really useful for like operators. So we wanted to make our own Wikibase, and we want this to be really tailored for internet resources. So we have an experimental prototype that we call the Internet Yellow Pages. And this consists of Docker containers that will just provide all the software. And but the main part is also the Python script we are making. So those scripts are fetching data like from online data sources like RIPE, PeeringDB, Spamhaus, and it's gonna push this to our Wikibase. So we designed those scripts so we can just run it frequently, so our database can be updated automatically. So we are developing this software, and we have one public, and really it's still at the very experimental stage. We have one public instance at this URL iyp.iaglab.net. And currently we have about 12 data sources. So we get data from PeeringDB, MANRS, got BGP data from Routeviews, DNS data from Rapid7, block list from Spamhaus. Then we have different rankings like srank. Trunco is top domain list, a bit like Alexa. We got the eyeball estimate from APNIC. We have a script that can fetch data from the Alice looking glass, so from route servers. And we currently have data from the DKIX route server. It's the first route server we start playing with. But if you're running the Alice looking glass, it's very easy to for us to get your data to. And we got also like RPKI data. So using all these data sources, then we have our wiki look like very techy. So we have like here an example. You can see it's a prefix, and we're going to have information related to that prefix, like where it's originated from. Here you have two entries because it might come from two different data sources. So we always put a reference to the data we had. So we have a URL to the data source and where that data is from. So as you can see, it's less general than what we had in Wikidata. So that's the graphical interface. What I'd like to show is some example using the querying UI. And I will try to show two examples. The first one is looking at prefixes that are reported by Spamhaus and that are also seen at a route server. So if I switch to the website, so this is the query. It's in SPARQL. It might be a bit complicated at first, but it's a very powerful language. And so that query just gets, as I said, the prefix that appear at a route server and that are in the blacklist. So that gives us this about 300 different prefixes. If we click on this link, it's going to bring us to the page of the prefix. But for this demo, I'd like to show this graphical representation. So in this tool here, we can browse the graph. So here's the prefix that is reported. So if I click on it, we're going to see the different properties of this prefix. And so we can see here it's reported in Spamhaus, and it appeared in two different route servers. So if we click on this node, you can see that it's a route server for DKIX Frankfurt. What else could we see? So if I go back to the prefix, we can see that. So that prefix is originated by .as, and it got a raw for .as too. then we can just continue and browse the graph for some time. Then we can have information about that AS too. And we see that that AS is also reported in a Spamhaus. It's a different Spamhaus block list. So also reported there. And it's from Russia. That graphical interface is just good to browse the data like that and to do this kind of demo. But there is in fact a bit more information on the pages. So if we look at the page for that prefix, we could see, for example, that so the prefix was imported to the route server from different AS. And again, so this is just good for demo and just to play with it. But if you want to integrate this kind of thing in your workflow, the website also provide code. So if you're like me, you like Python, then you can just grab this code, and that code will just fetch the data, and then you can just use your data in your own program. Okay, so that's the first example I wanted to show, and this is an example that just show that we can seamlessly go through a lot of different data sets. We went through data from a route server, from Spamhaus, data from BGP and Routeviews, and it's very transparent to go through all these different data sets. So if I still have time, yeah. So I'd like to show a second example where here we're gonna look at IPv6 prefixes from Netflix that appear in different route servers. And this time I'd like to use a different representation, so I want to use this. In this representation here, we have on the y-axis, you have the prefix. And on the x-axis here, the column shows 3 different IXP. So we have DKIX Chicago, Frankfurt, and Madrid. And the block here will show that the prefix, it means that the prefix appear in the route server here of Chicago. So the first prefix here appears in the 3 IXPs. What is interesting in this representation is looking at those green blocks. So that means this prefix appear only in Chicago. These 2 prefixes here, the 2 green one, appear only in Frankfurt, and these 2 appear only in Madrid. The color is in fact the dominant domain that we found in Rapid 7 for those prefixes. And you can see that those green one correspond to Netflix video. So it's a good way to like very quickly compare like what are the prefixes that are announced by Netflix at those different IXPs, and how they manage their prefix, like how they decided to have some prefix announced in Chicago and not in the other one. And the domain name information also give us some more insight into what are the resources that correspond to these prefixes. Okay. Again, I cannot stress it enough. This project is just starting. We've just started this year, so it's just a few months old. And there is a lot of challenges. I don't have time to go through all of that. We are still like dealing with some of them. Maybe I could mention, like for IXP, one of the challenges we have is to uniquely identify IXPs. It's not as easy as for ASs, where there is an AS number. And there is a lot of more work to do. We are not really a big fan of the interface, the web page, the wiki web page. We'd like to have something that is more designed for network resources. And of course, we are planning to add a lot more data set to that. And so this is my last slide. I just we would just like to know what are your favorite dataset? What we like to see in this wiki? How would you use this kind of platform? And I'd also like to say about the advantages of adding your data. So if you make a parser and you can add your data to this wiki, it really augments your data because as you add it, it will be connected to all the other data sets that are already out there. So it really gives you more insight into your own data. And of course, if you have confidential data, you can just start your own. We provide all the software, and you can play with that too. And that's the end of my presentation. So you have our emails here and the link to the website. Thank you very much. If there is any questions.
Okay, thank you for the presentation. I don't see any questions in the chat or the Q&A. Excuse me. But I do have a comment for you on identifying IXPs. So something that we use in the IXP database, which is an IXF ID, and each IXP in the database has a unique identification number. So this is already being used by other external organizations. For example, MANRS are using it, and others as well, because like you said, yes, there's no way to identify IXPs uniquely with networks. It's easy because you've got their AS number and there's definitely no duplicates of those. The IXF ID is being used as a unique identifier for IXs. So if you want to use that, you can do.
Yeah, thank you. Yeah, we'll definitely add this. Yeah.
Cool. So I have another question, which is from an anonymous attendee. Great presentation. If you aren't aware, the ASD Australian Signals Directorate also have an open graph visualization tool called Constellation. I'm sure they would be interested in collaborating with you.
Okay, I'm not aware of this, and yes, as researcher, we are always open to collaborations. We are, especially now, we're just starting this project, so it's for us like that presentation was really a good chance to just like give like what are the ideas we have and see like how people can use it and see like if there is already other project or other people working on this kind of thing. Yeah, we are surely interested to collaborate with them.
Yeah, good stuff. Are there any other questions? No, not at the moment. Okay, so if you do think of something after the presentation, then you've got the email addresses there, so please feel free to contact either Romain or Emile, with anything else that can be helpful for them in their project. So Emile and Romain, thank you.
Yeah, thank you.
Thank you very much.